Hi, my name is Mike Palacios, and welcome to week 7. We're at the home stretch where we're going to do a demonstrational speech. And there are many ways to demonstrate many things. In this case, I'm going to demonstrate how to write a program very briefly and easily. I have a background not just as a student currently enrolled as a computer scientist study, but also I've had it in the past where I did middle school work with Old Basic. I've worked in high school with C and Pascal in the past, as well as some college studies in the past. So I have a very fair grasp on how to write a program. And the whole point of writing, for those of you who are curious as to what we do, some people think it's complicated or it'll look like this. But it's not. It's not that complicated as you would think. As a matter of fact, it just boils down to a simple set of steps here, which I'll go over with you. First, in the start of this is we're going to ask the questions, how we break down the problem, analyze it, find out what we can do to make it simple. In other words, we tweak it down to where we know the very small step-by-step, like a cookbook construction. We start off at the first step of getting the ingredients. In this case, try to figure out the variables. Variables are the factors we don't know until somebody tells us that. Constants are the exact opposite. It's something that's always going to be, like if you were talking about pi, it'll always be that same number. No one's ever going to change that number, ever. That's a constant. Very rare will that come up. It's more variables that'll come up. So you have to compile all the factors that are involved and break it down. If there's an equation, note it down, etc. It's like brainstorming. The next thing is to create a flow chart. Now, what a flow chart's going to be is it looks like basically a set of shapes that are, pointing in a direction. Now, each shape has a meaning. This shape right here, for instance, is the start and end point. You're going to see one at the top and one at the bottom. The one that says start at the top and one that says end at the bottom. That's typically how all programs will come out when you create a flow chart through it. That's fine and dandy. At least we know what a start point is. This arrow points the direction. In other words, like the name entails, it's a flow chart, so you're following the flow of how it goes. Usually from top to bottom is how a program's created. That's what they call a top-down design. Then you're coming towards where the next one is the input and output. Basically, we're getting either the collecting of the data or we're going to show you the data. That's what it basically is. It's just information being shared or collected. That's all that symbol means when you're writing it. It's just little notes to let other people know. That's why the shapes are important to know. It's to let the reader know what they're talking about and what direction they're going with the program. The next one here, process. Now, process means we're going to call it something. We don't know what, but we're going to call it something. It's something that the computer doesn't know until you give it a name. That's part of why you need a variable. You have to name it. Like, for instance, if I wanted to say test grades, well, I would call, let's say there are 5 test grades. Obviously, I could say test grade 1, test grade 2, test grade 3, test grade 4, etc. And the whole point of that is to give it a name, not just any old name, but a name that people can kind of figure out what you're talking about. So that way, as the programmer looks at it, or another person who understands it looks at it, they can say, I see what he's doing. I see where you're going with this. It's to make it simple for anybody. And the final thing, this little diamond shape here at the bottom, is called the decision. Now, what the decision is like some things require a determining factor to whether it's going to happen or not. Let's just say, for instance, you were dealing cards in a poker game. Well, obviously, 7-card stud requires 7. So you pass out the card. Picture the programmer being the dealer. I passed out 1. Is that enough for 7? No. Then continue on. And it continues until you hit 7. Then it'll go down to the next step. That is called a loop, which is very common in programming. That's why decisions, when you see the diamond, usually means a loop is coming. And let me tell you, from my personal experience, you cannot escape loops in programming because they are that big of a deal. The next thing, after you've done all of your organizing and preparing, creating flowcharts, your next step is to construct it or to write it. Now, simply put, you have to type it into what is known as a text editor. And all it is, it looks like a WordPad or a word processor, and all it is you're writing the code. It's like writing an essay or term paper. Basically put, you're writing the code so that every step is illustrated by that language. No different than if you had to write in Spanish or write it in French or any other language. Just the difference is it's in a language that it's within the parameters of that computer. The next step is to compile. Now, compile means like going to your teacher, proofread your work or somebody to take it to proofread before handing it finally to the teacher. They're going to edit and comment and say what they feel is wrong. In this case, it's going to look for 2 factors. Syntax, which is grammar, punctuation, etc. See, it's no different in a computer language. It's going to look for those flaws because it won't read it. It has to understand it or it's not going to do the instructions. So it's going to say, I don't understand, and you have to clear it. And the other one's logic error, basically logic error. Basically you put something out of order, and you need to fix it to where it's in the right sequence in the language. After you've tested it, and let's say you had errors, you go back, compile it again, and it works this time. Then finally it runs. And what that means is just it does what it's supposed to do. Nothing more, nothing less. It spits back the answer you're expecting or that it needs to give for it to run. And that's all there is to it, folks. It's a very step-by-step process. Programming is step-by-step, just like math, just like writing a paper, even giving a speech. It's just like that. And an example of a good flow chart for all of you folks is right here. See how the arrows point the directions, even with the diamond's decision. See how everything just kind of follows through. This is an example of what a flow chart would look like. In conclusion, we have demonstrated how to prepare and write a program going through breaking down the problem, listing the factors, making the flowchart, compiling, and executing. So I sincerely hope this was a very informative yet helpful instructions on how programmers work and in essence, what I plan to do in the future. So I thank you for your time and have a great day.